So let me start off with Kiran Nair, CTO of Adani Group.
I'm heading technology for Adani Green. So that is a renewable energy arm of Adani. So there are quite a lot of questions Gobi has thrown, in a couple of minutes. Typically, for last 3-4 years, we are trying to find answers for all these questions. So still I will try to put some sort of, episodes from what we recently just go through when we are just talking about edge and cloud. In fact, in the last session, somebody was asking about the power growth. Whether, in the last question, they were literally he was pleading for a question, and he asked whether, as a country, are we equipped for the growth of electrification? I will just start from there, then I will just come to AI. As we speak today, we have got close to 400 gigawatt, that is the installed capacity of our country. And out of that, 200 is from coal, the conventional coal. Renewable contributes for 100 gigawatt. When I'm saying renewable, it is pure play renewable, wind and solar. Why I am emphasizing on wind and solar? That is a talk of the town now, because of the Paris event of, bringing global warming 2 degrees below the industrial era. Everybody wanted to infuse more and more renewables into the system, right? So between solar and wind, we have got 100 gigawatt. That is 25% of our national installation capacity, and another 50 gigawatt from hydro, the large hydel plants, right? So this is the conventional system. The grid works. By looking at the growth set up by Niti Aayog, we are expecting this capacity to be doubled by 2040. So we are talking about 800 gigawatt of power, even looking at the conservative growth after COVID, right? So this is the growth we are expecting, and 450 gigawatt is what set up by Indian government. That has to come from renewables. So these are the numbers. So where the edge is coming in all these things, I will just come to that. Traditionally our grid has been designed for one directional use. Somebody will produce, somebody will consume, somebody will monitor, somebody will bill, somebody will pay, right? So this is the way, the entire grid has been designed as we talk. But now, the distributed grid, we are talking about the microgrids. The concept of consumer is getting lifted away. Now everybody is wanted to become a prosumer. There are places where people will produce as well as consume. This is the meaning of the microgrid, right? We are talking. I have got storage system, I have got small scale solar panels, I have got small wind turbines. So when we do all this networking, right, still it is not in the mainstream, but of course that is something that we are going to see in the upcoming days or months or years. One of the key element is going to be how quickly you are taking this decision. When you have got a decentralized system, which in the same time will stand as a standalone system and it will talk to the grid. These kind of things are already tested somewhere else in the world. It is not, we are not going to be the first people to do. If you read about Brooklyn grid, microgrid, you will read all about this. So how quickly you just, respond to the change in environment. So that is where, that is going to be one of the biggest use case of edge computation going forward. Because of two things, when somebody was asking the last question, when you will take a decision whether it should be on an edge or a cloud. For me, it is very simple. If you want to take a decision with available data without correlating with anybody, anything else, then it can be on cloud. With the available data, at that moment, if I want to take a decision, a car is coming to me, I have to just jump. I don't need to think about past, how I responded to this situation in the past. It's a edge decision for me. If I need to look at some pattern, if I need to see some algorithms, I can take a decision, I can have a time to improve an operation, then I can have that on cloud. So this is the biggest impact I'm seeing. As a country, we are going to see, especially when this related to the green energy and renewable energy segment. If you ask me today where we are using, as a company, we invest a lot when it is coming to security and safety. Especially, Gopi was giving an example of image analytics. So when a crane is moving, when an employee is standing without helmet, right, you don't need to think historically how it performed. Straight away, you have to have an alarm saying that, I'm seeing exception-based management. I should raise an alarm. Either I should stop a crane or I should be able to ask that person to move. So these are some of the use cases that we see, especially with a lot of IoT penetration in the distributed grid side. We are seeing a lot of use cases for edge. And as I said, this is going to be, at least from a renewable energy perspective, I see it is going to be a huge market. At least 25% of the country's total generation. Before handing over the mic to my fellow panelists, just to give a context how fast, these responses will make an impact. One of the biggest challenge for all these renewable energy penetration is a change in weather, right? Suddenly, if the cloud cover is coming, solar will drop the production. It will straight away, it is going to impact the frequency of the grid. 9 out of the 10 times, grid will just topple. Right? This is one of the challenge, as a renewable energy penetration we are facing in the country. Day before yesterday, for Gujarat site, the site is of 1000 megawatt. There is a cloud penetration. In 1 hour, production came down from 1000 to 200. So that is 800 megawatt of drop in an hour. Just to give a context, entire Bangalore in a day uses 2300 megawatts. Entire Bangalore city. And that is 1/3 of Karnataka state's consumption. So we are talking about 1/3 of the power is getting wiped away in a span of 1 hour. In that aspect, you don't have time to check, where are my reserve solutions are there, how I will be able to ramp up, ramp down. I think these are the places, where we are going to see a huge penetration of cloud computation. Immediately the change in weather, how I have to respond. The demand drop, how I have to respond. The consumption up, how I will be responding. So I will leave the mic to my fellow panelists. Let me hear, from them. We'll come back in case of any specific questions.
Thanks, Kiran. Yeah, when you have such scale of installation, gigawatts of power through, let's say, a wind farm or solar farm, and you need to make decisions because the wind farm is not stationary. It is moving and trying to maximize its output. It's sharing the wind with the neighboring turbines and trying to maximize the output of the farm. And, the renewables and fossil fuels are trying to dance together so that it's as green as possible. There's enough use cases, but for both cloud as well as for the edge. And I like it that where you can do it with data which is available right then and there, and where latency is important, do it then and there, right? So I'll move now to Binoy before coming to Rohit. Rohit has a different flavor. Binoy is again a consumer in a way of AI in his automotives and maybe in the factories also. So Binoy, you can take a view on this.
Sure. Thank you, Bobby. Good afternoon, everybody. So I represent Mahindra. We design, engineer cars. So now AI in automotive. Now a lot of questions were around automotive. So I see that there is a sense of understanding of automotive, and now with our vehicles, Mahindra has developed projects. XUV700 as an example, where we have ADAS. There is Alexa running in car. So that's a very good example of running an voice recognition engine on the edge. Right? So the question of AI on edge, to me, as a vehicle design, engineer, I would love to have everything in edge. Now that is not possible. Reality is that the compute power is not there, right? So that's when we have to have the balance between edge and cloud. And coming back to, I think my answer is very consistent with whatever you heard earlier. Anything on real time, edge. Anything we can afford to do on a time domain, a delayed time domain, on the cloud. Also, there is another aspect to it. Anything to do with big data, where we have to do preventive maintenance, analytics, and usage of the vehicle data to improve the performance of the vehicle on an ongoing basis, especially valid in EV use cases. So your battery prediction algorithms, charge prediction algorithms, All of that, you don't need to necessarily do it in edge. You need to do a little bit of that. And you also need to do a data packaging in the edge. That's how we are defining and deciding what is on edge and what is on cloud. Now, the other aspect, what is happening in the automotive industry, everybody knows there's enough sensors in the car. Now the new architectures which we are working on, we have Ethernet in car. You're not restricted to the data pipeline is bigger. You're no more restricted to the minimal data transfer protocols of CAN. You move to CAN-FD, you move to Ethernet. We have got huge video data streams going on. ADAS is a very good example of big data to be managed. So the data generation in the vehicle is much higher. So there's an opportunity there. Now the convergence of 5G. So there's a lot of things coming together here. You're getting a lot of vehicle data available in a bigger data pipe. Now you have a capability to connect on a faster network onto the cloud. And thanks to Qualcomm and NVIDIA, you have huge compute power available. So then you have to, the whole dimension is now different. We have to now be very smart about what makes a lot more sense to my end customer. What is the value to my end customer? So there is a cost angle, there is a time domain angle, and the value proposition. So these decisions on AI on edge is triggered by all these factors coming together. And the cars of the future is going to be autonomous, is going to have a lot of data, and connected is a given. Now connected is a given, especially if you look at the scenario in India. We have the connectivity in India, connected cars happen mostly because of the customer need for infotainment. It didn't happen because of the telematics requirement. It didn't happen because of the regulatory requirement. It actually happened because of the streaming audio and the streaming video and the Alexa use cases and voice recognition use cases. So that's also creating a lot of use cases to the point which Gobi showed about the video pre-processing. Now you get a lot of use cases on video streaming into the car when you have rear screen or a passenger screen. Now that's where there is a lot of opportunity to improve the video performance using AI algorithm on the edge. So automotive as a product, from an IoT perspective, there's a huge growth, exponential growth happening because of whatever the factors I mentioned. There's multiple things happening together. And these are all feeding into making a better car. No, that's the aim with which we visit and design vehicles. And AI is a huge enabler on the edge. Now, I'm not touching upon the non-product and aspects of it. I'm not talking about the manufacturing aspect. I think there's a panel which covered that earlier. That's another huge automotive use case out there. Thank you.
Thanks, Binoy. My wife's first car was a Scorpio, and today the XUV 700 is on a wait list for some 7-8 months, I understand. 8 months. So congratulations. I think that's something which is desirable in a way.
We are very proud of that product, but we are not necessarily happy that you have to wait.
Yeah. So we'll move on to Rohit. Rohit's company's products, Rohit's products make a difference in the automotive space. It has made a difference in all our phones. I'm sure they have other plans as well. And they generate tons and tons of IP. So he'll be, a great person to interact with on edge and AI, and especially the question about, the computational power on the edge, if you can take that up and other things.
Sure. Thanks, yeah. So maybe just a little bit about myself. So, I lead wireless and machine learning R&D at Qualcomm India. So hopefully, that kind of sets the background of where I'm coming from. I've, for long been a wireless guy. I've been at Qualcomm for about 20 years now. But the last few years, I've been looking at machine learning R&D as well. And as a lot of other people, panelists have mentioned, it's really interesting to see how these two very key technologies are coming together as well, right? But what I want to do here is maybe just kind of take a step back and provide a little bit appreciation for what are the types of technical challenges, what are the problems that, that from an R&D point of view, we are looking at, especially when it comes to things like ADAS, right? Because that's a really good example of AI at the edge. Of course, there's a lot of things that get done on the cloud there as well, but there's a lot of things that happen at the edge there, right? So, I mean, if you look at the car of today or the car of tomorrow, as my panelists from Mahindra, of course, will know very well as well, right? The amount of electronics and digital stuff there is just, it's outstanding, right? I mean, I don't remember a single platform, ever in the past having so much electronics that a car is likely to have, right? You can really name it. It's got a CPU, it's going to have a GPU, DSP, artificial intelligence algorithms, sensors, cameras, near cameras, far cameras, back, rear, ultrasonic sensors, whatever thing you can think of, it's going to be there, okay? And some things that I probably don't even remember, off the top of my head as well, right? And the question to ask really is why, right? Why is it that there's so much sensors going into cars, right? That's a really good question to ask, right? And that sort of pertains a little bit to one of the questions that I think Dr. Gopi has on the screen as well. What can you really do with multiple sensors, and where does machine learning fit in there, right? And that's a problem that I think companies like Qualcomm and other companies have thought about for for quite a few years. So if you look at this whole gamut of sensors, cameras, they all have slightly different, you can say, physical characteristics or physics characteristics, right? You take, for example, radar, right? Radar is really good in low lighting. It's good, when the weather is bad, for example. It's good for long distance as well, right? LiDAR is a little different. LiDAR allows you to kind of sense depth, to have a good 3D view of objects in front of you. Cameras are very different. Cameras allow you to do image recognition, object recognition, those kinds of things. Uh, but then there are, sort of other sensors in the car as well, which are more of the wireless type sensors. If you take, the cars of the future are going to have, V2X, 5G V2X as well, right? And what that allows you to do is to look beyond the horizon. All these sensors that I mentioned earlier, like radar, LiDAR, ultrasonic sensors and so on, they are all what we call within horizon sensors, right? But then with wireless, you can go beyond the horizon as well. You can sort of start figuring out what's going to happen, around the turn. Is there a car coming around the turn, for example, right? So the reason you really need all these sensors is that, I think in Qualcomm, we often use this term of, a low signal to noise region, right? So a region where, there's not really that much strong signal coming out from your sensors, right? So how do you make sure that you're still making good decisions when the signal to noise ratio coming out of your sensors is not very good, right? And that's where the power of all these sensors, cameras, everything comes in. And the problem to solve really is that how do you combine all this? And clearly machine learning is a part of it. How do you combine all this sensor information, fuse it, and come up with something that just always works, right? I mean, like, for example, if you're, even if you try to go to level 1, level 2 ADAS, right, which is like the first steps towards autonomous driving, which has really safety features, right? Collision avoidance, or if you have automated braking, those kinds of things, right? But even for those to work, you have to make sure that it works when there's poor lighting, or when the weather is bad, all those kinds of things, right? So that's where the fusion of these sensors really comes in, right? And and sort of, if I look from the engineering side, right, even once you've done a lot of R&D on this, you have good algorithms and so on, the problem that you run into then is that the amount of horsepower that you require to run these machine learning algorithms is quite a bit, right? You have to, I mean, these are really complex calculations that you have to do, and you have to do them with very low latency, because obviously this is a, it's something that pertains to safety, for example, in a car, right? So there's a lot of engineering that goes into how to optimize the networks, but also how to get better, neural network accelerators or hardware accelerators to run all these machine learning algorithms. Then there's a whole machine learning stack in between that also we work on. And there's a lot of work that goes into how do you optimize, everything that's running on that stack. So that's kind of where I wanted to just spend a little time, just, yeah, talk about. That's one really interesting technical problem. I wouldn't say it's fully solved, but I think there are good steps taken in that direction. And as the state of the art of, of some of this physics, semiconductors keeps moving, I think these will, get solved in a better way over time as well. Yeah.
Thank you, Rohit, and very keen insights on the fact that you can combine multiple information, and the some of that probably will give you intelligence, which if you look at each individual sensor independently, you might not get. There is a physics question which can be debated around that, but that's for another day. But emergence of systems, I think, is something that is going to be sought after as we look into the near future. So we have just sufficient time now to open up the audience for audience questions. And I will start with, there was a gentleman here around this vicinity who had a question. I asked to hold the question. If not, what happened? Oh, he got upset with me. But yeah, the floor, yeah.
Hi, Dhananjay here from TCS. So my question is on edge computing versus 5G. Are they competing each other or they're complementing each other? The reason is that when it comes to 5G, all the cloud providers like AWS or could be Azure, they're already coming up with the AWS wavelength plus 5G, where it will reduce the latency and then you can do all the workload from the cloud itself.
Yeah.
Okay, so they're telling that there is no need for edge computing. So when we are planning for such a situation, should we go for a high investment on the on-prem solutions, and then later we come to know, okay, 5G and cloud, they are sufficient to reduce my latency. So those kind of confusions are still there with the digital transformations versus edge versus 5G plus cloud.
Thank you.
Yeah.
Dhananjay, is it?
Yeah. So
You're not angry with me, right?
No.
Yeah. Okay, thanks, Dhananjay. I think we got the question. I'll just start off by giving you an answer from a field which is not represented here. So I mentioned earlier about content delivery costs. Those costs are not coming down, and 5G will not bring those costs down, because there is a cost of taking content across from point A to point B. And in fact, those costs will go up because the quality of video, for example, is only increasing, it's not decreasing. And more people are viewing better and better quality videos. So there is a burden on people like OTT players which need to be addressed. Otherwise, they will never become profitable. That's a field which is not represented here. So I thought I'll start off with that, and yeah.
No, I was actually talking to, no, your question is actually a very relevant question from an on-prem to cloud, from a digital transformation point of view. So there is definitely, a lot of HPCs which has been on the server side, on-prem servers, is moving to cloud. This is happening, right? And but in the product side, the edge we are talking about, at least I am talking about, is the vehicle. Now 5G is actually an enabler to do more edge AI, because you get a lot more use cases, right? With 5G, you get a lot more possibilities to do more AI-driven features in my car. So 5G will only enable more edge AI, is my view.
Yeah.
Okay. Of course, Qualcomm, NVIDIA, and Intel has to help me to get more edge compute capability. But the 5G is actually going to create more use cases for you, for the vehicle point of view. But on the IT infrastructure side, I do see that happening, that on-prem is going away and HPCs on cloud is the new way of doing things.
So thanks, Binoy. There will be a brief session later which will also highlight the reason why you should think about all these elements. It's not an or, right? You will do things on the cloud. You will do things on the edge server, and you will do things on the edge device.
One thing to add there, it is one more aspect other than technology, what we are just missing out here is, the more and more data is coming to the edge side, I think sooner or later we will be having this geopolitical issue of the cloud hosting also, right? Now we are exposing it to more and more end user data. Now we are really not stringent about the data can be in India, it can be outside. Of course, I mean, there are companies start talking about it. I think the more exposure we are going to have on this data side, we are going to talk more about that. This edge is going to be a solution for that as well, I think, right? I mean, where you are generating the data, you are going to consume that particular thing. Till a certain extent, that is going to eliminate that particular part. Even to add one last thing, uh, even at the cloud, even the enterprise solutions today, even if you're talking about SAP, Oracle, or project management solution like Dassault or Bentley, for the latency, these systems are replicating the data where they are consuming it. Even if you are just hosting in the cloud, maybe in Mumbai, even if you are in the same geography, if your consumption is in Ahmedabad in our case, we are replicating that data. If you are looking at the license module, you will see a module where they're replicating it for a latency issue. So this debate is going to be there, but for sure, the market is going to find an answer for it.
And maybe I'll add another thing. I think Dr. Gopi hinted at that. You can extend your question actually to not just edge and cloud, but edge, cloud, and the local device as well. Because, in fact, I myself have looked closely at some applications where, the trade-offs between what you run locally on the device versus what you run on the edge versus you run on the server just changes so much the moment you change your metrics slightly, right? So I think in the end, it really depends on the application. But for sure, there's going to be intelligence, some of it at the end device, some at the edge, and some at the cloud, right? Yeah.
Thank you. Yeah, I think this, no, there we have time, so we'll go with this gentleman and then go behind. Yeah, if the mic can be passed to the wonderful gentleman in the coat.
Sorry. Good evening. My name is Surkada Shetty, and I'm CTO and founder of Prime Sophic Technologies. My question is to Rohit. Now, we have always seen the trade-off between the performance and security, and that same trade-off would be applicable in AI, whether it could be edge or on the cloud. Now, what measures have you taken in Qualcomm, and if you could give some insights on those lines, it would be much appreciated. Thank you.
No, sure. And I think Mr. Binoy probably may have something to add as well, but I can give you a couple of things. I think you mentioned security, right? That's what you wanted to. Yeah, so I think if you look at some of our newer, the chipset architectures that Qualcomm is putting out, a lot of attention has been paid to creating, trust zones and secure processors. I think we can have a separate discussion on that. But that's certainly, sort of, one big part of it, right? Of getting the security. Even if you look at evolving standards on the wireless side, right? There's much more newer ways of doing security that are coming in as well. In fact, as we move towards sort of 5G advanced, there also some newer techniques are coming in terms of security as well. So maybe I'll leave it at that, but I'm happy to have some more discussion later.
Thank you. And there was one more question, if you can hand the mic back. Yeah.
I go back to the question Mr. Dhananjay asked. Okay, this is related to, I just want to, instead of cloud providers, I will say that I'll put the service providers, telco service providers like Verizon, AT&T, and how will they make money? You see, they are all putting money into the 5G networks and thinking that they will be able to stream all this IoT data coming back to cloud or enterprise, etc. So that is going to be cut off, right? How will they make money? That was, in fact, that was a question I had earlier also. Yeah.
No, I think you can answer it.
I can give some of my thoughts, though I'm sure they have people working on their own business cases, right? But I think if you look at the evolution of wireless networks from 4G to 5G, right? The one thing that's changing in my view, right, is that it's not just about wireless anymore, right? If you look at 5G and as we move forward beyond 5G as well, right? All these wireless interfaces are being designed keeping data in mind, right? So I think the opportunity for not just operators, but for many startups, many companies, is what can you do with that data, really, right? I think that's the opportunity. And, of course, operators are right there, right? They are, all the data flows through them. A good example I'll give you is something like private networks. And I think, my esteemed panelist is from Adani as well, right? So I think there's a lot of interest in private networks. There are huge opportunities to do things there that are maybe operators may not have done, just as yet today. So yes, those kinds of things. You can build on top of data, applications, those kinds of things. Yeah.
Kiran,
So
do you
one
have
clarification.
Yeah.
One clarification. As you told, for hybrid cloud, interlocks will be in the on-premises. For example, we are working in Mysore automotive axle plant. So in interlocks or controls, PLC controls will be in the on-prem, Mysore. But data with respect to traceability and all will be fetched to cloud, Pune, for example. So if this is the case, commercially, how we have to procure both the license, or it will be one license can feed for both of the purpose.
So what license you're talking about? Sorry.
License in the sense, if, for example, the cloud license, ThingWorks license, PTC ThingWorks license, one ThingWorks license will serve for both on-prem as well as the cloud. Or commercially, we have to procure both the things.
No, I would submit that maybe that's not an edge AI question, it's a business model question. But if somebody has a different answer, you can.
Typically, if it is a one instance at the server level, you should be get away with, I mean, one license. Again, it depends on the solution to solution. I'm really not sure what exactly you are just asking.
See, the controls or interlocks in the assembly line will be, the real time, will be in the on-prem. Okay, it's like a hybrid. But data with respect to the traceability, everything will be fetched to cloud through PTC cloud. Here we are going to maintain two licenses or two servers. For that, if we are going to maintain two licenses, then we have to commercially, it will be not cost economical to us. This is what my question is.
I mean, to the extent I understood, I can try to throw some light. You know, I have seen, for example, even in our case, right, as Qualcomm, I think there are some companies we work with where maybe we use some software products provided by them, and as you know, things are moving to cloud, the way we structure those licenses has changed a lot, right? So I think it's not just a local license versus a server license. We just think very differently about it, right? So maybe that helps, right? Yeah, to answer.
Yeah, absolutely. I think it's a business model question from your providers, but more and more of them will gravitate towards microservice endpoint as an example, if that's conducive. Everything else should be transparent to you. Where you're getting your service and where the value is being added, that should be the basis of your value and hence their return. Yeah, I mean, but that you cannot hold them accountable for my statement here. just giving you an idea.
So Gopi, Chandra
yeah.
here, I just want to answer him,
Yeah.
okay, because I'm one of the adopters of the
Okay,
hybrid.
so you answer, and there's one more question here. We are seriously out of time, so then we'll go ahead and bring the next portion. So please go ahead, Sanjay.
Yeah, so for the case, whatever he's talking about, PTC ThingWorks, and where it is hosted on-prem and where you're looking at cloud, right? So there are inherent advantages of having it on cloud or having it on-prem, right? On-prem basically for security and important activities that you're trying to do, it is to be very native to where you're sourcing the data. It is better. ThingWorks has got the best performance what you can do. But if you have to service it with cloud, you have to go with a real cloud provider, either as an AWS or as an Azure. So there is no choice. You are operating on a hybrid model. You have to have AWS, Azure on cloud.
And probably you're storing data on the cloud, long-term data, and data storage won't come free. So
Correct.
you're doing some data storage and you're paying for that.
Yes.
You're doing some edge compute and you're paying for that.
So PTC is nothing but a digital mirror of your edge is what I would like to tell.
Okay.
Yeah.
Thanks for the clarification, Sanjay. Can we take one last question, please? And
Yeah. Hi, this is Sai from the Times Group. This is just an extension of the previous question. So I wanted to know, like, what are the advantages of companies going for private 5G networks over leasing it from telecom companies? So what would be the benefits for conglomerates like Adani and Mahindra Group? Thank you.
I would again go back to the last session's last question, right? At the end of the day, it depends on the landscape of the business you are in, right? Which are the business you are in, vis-a-vis what exactly you anticipate your cost, if you are just buying the service from somewhere else, right? In this case, either from Tata's or Bharati or Reliance or wherever. Vis-a-vis, I mean, next 5-6 years where you want to expand. It is not only about expansion, which are the companies you want to acquire, where are the new domains you want to be in, right? So it is clearly a business decision rather than, I would say it is a 75% business decision and 25% technical decision, right? In our case, right, it is a natural extension. We have got data centers. We are one of the largest data center provider in the country, right? So we have got our power plants spread across the country. We are operating at 120 different sites. Our transmission assets are across 13,000 kilometers. Our power plants are at 13 different places. So, and we have got a data center business, right? So it is at the end of the day, you know, how you want to just connect inorganically or organically, whatever be the way you just called, how you want to connect and leverage it. So, and at the end of the day, I mean, whether you have got that capacity to take that call and just go ahead. And one thing just to add, this, from my experience at least, working in a renewable energy segment, this is not an easy journey, to be frank, to adopt out of the box edge solutions. In fact, we are on a boring industry, right? We are talking to machines. We are not talking to either flashy, jazzy cars or human beings. It is actually a boring business, right? I mean, taking the edge computation and getting something happen at the machine level. And two major problems I just saw. I'm sure, I mean, many of you also might have just saw the same issues. One is the integration side. I really feel, you know, when you are just having these pilot projects, right? You will be having multiple pilot projects of IoT boxes, IoT gateways, whatever it is. At least in my experience, we have got 10 or 15 pilot projects we have done at multiple scales in Adani. And we used to say that soon we will be having more pilots than Indigo when it is coming to, you know, this number of pilots we do in multiple places. The integration is one bit. Unless otherwise we can integrate to the enterprise system, I think it will take more time for us to establish this capacity. Second thing is the cyber security side also. Before cyber security, I wanted to also say the product life cycle management. It is very easy to conceive a solution and go and put something. But how you are going to manage the solution, how you are going to give the service to that particular solution, especially you are talking about lakhs of devices. It is not, I mean, one or two devices, right? And the last is, you are going to be the number one enemy of your IT team if you are going to tell them, you know, I wanted to deploy this particular site. Straight away, he will come and ask, what is your cyber security policies? Let us go through architecture review board. And let us see, you know, I'm opening whether this is going to talk to my central system or not. If not, I am okay.
Yeah.
So I think we have a quite bit of gap when it is coming to real operational things. I mean, from my experience at least. But it is much better than 3 years back when we were talking about, you know, IoT and edge computing.
No, great points, Kiran, and let's thank the panel, wonderful inputs.